Our next type of problems are called work problems. When we're solving work problems, we have two people working together, or maybe even three, or working sometimes against each other. When we're trying to work together, we're taking 1 over the time, first person's time plus 1 over the second person's time equals 1 over the time together. So for example, Paris can wash her car in 4.5 hours. So that's Paris washing by herself. Her friend Celia can wash the same car in 7 hours. Working together, how long will it take them to wash the car? So the thing that I'm looking for is the time together. It's in the question there. So I'm going to let x be equal to the time it takes them to work together. So the formula says 1 over plus 1 over equals 1 over. So Paris can wash her car in 4.5 hours. So 4.5 hours, well, that's really in mixed numbers. 4 times 2 plus 1 over 2, which is 9 halves. So I'm going to use 9 halves here. And Celia can wash the same car in 7 hours, so that's 1 over 7, equals 1 over the time together. Well, how much time does it take them together? Well, I don't know. That's what I'm trying to figure out. Okay, so some people might be a little bit concerned about a fraction over a fraction. So let's see if we can't fix that up a little bit nicer. If we have 1 over 9 halves, that really means when we're dividing a whole number 1 by 9 halves, well, I can rewrite that as 1 multiplied by its reciprocal. So when I multiply that, I'm getting 2/9. So 1 divided by 9 halves is actually really 2/9. I think this problem is going to be a little bit easier to solve when we have it written this way. Now let's look for our LCD. The LCD between 7, 9, and x is just going to be 9 times 7 times x, or 63x. So we have 63x. I'm going to multiply it on every single numerator. So the 9 and the 63 divide out to 7, so that's just 2 times 7x. The 7 and the 63 divide out to 9, so that's 9x. And then the x's divide out, and that's just 63. So we have 14x plus 9x is equal to 63. When I add these two together, I'm getting 23x equals 63. And then I divide both sides by 23. Okay, so 63 divided by 23, that doesn't come out really nicely. But let's see if we can't put it back in mixed numbers, because we don't talk about 63 23rds hour. We would talk about it in terms of whole hours and then parts of an hour. So 23 fits into 63 2 whole times. That's 46. So 63 minus 46. That's 17 leftovers. So 17 23rds hour. So almost 3 hours, not quite. It would take them to wash the car. Now let's go back and see if this actually even makes sense. If it takes Paris 4.5 hours to wash the car, and it takes Celia 7 hours to wash the car, would it make sense that the answer should be less than that if they're working together? And the answer is yes, it does make sense. If they're working together, it shouldn't take more than what Paris can do by herself, nor should it take longer than Celia can do by herself. It should take less time. A lot of students expect the answer to be like somewhere in between 4.5 and 7 hours, but that doesn't make sense. If Paris can do it in 4.5, she wouldn't want Celia's help if it would take her longer to do it. She would only want her help if it could be smaller than it. So I like to go back and make sure that it makes sense at the end. And clearly, if I take 2 and 17 23rds hour and plug it in for the denominator, I'm not going to get 0, so that check is sufficient. On this last one, we have working together, Joseph and Dylan can write the computer program in 11 hours. Working alone, Joseph can write the program in 15 hours. How long does it take Dylan to write the program by himself? So this time, the question is asking about Dylan's time by himself. So we're going to let x equal Dylan's time alone. Again, no picture to be drawn here, but my formula is 1 over plus 1 over equals 1 over the total time, okay? So we'll say Joseph is on our first one, Dylan is our second, and then together will be our third. So working together, Joseph and Dylan can write the program in 11 hours. So the together is going to be the 11. The reason why we do it 1 over is because in 1 hour, Joseph and Dylan can do 1/11th of the program. Okay, so we're talking about per hour. So each one of these is per hour so that we can get it in the same rate and so that we can add them together and compare them. That's why the formula is 1 over. So let's keep reading. Working alone, Joseph can write the computer program in 15 hours. So in 1 hour, he can write 1/15th of the program. So that's why it's 1 over. Or you can just memorize the formula is 1 over plus 1 over equals 1 over. That's another way you can just do it. But if you want to understand why, it's because we're trying to find the rate at which Joseph can do it in 1 hour and how much can Dylan do in 1 hour and then how much together they can do in 1 hour. And then we can compare these things using the same rate. Okay, so we don't have Dylan's time. So I'm going to put X for Dylan's time. My LCD is going to be 15 times 11 times x. Now, I know we can work out 15 times 11x, but it's kind of not necessary to do that. I'm just going to go ahead and put 15 times 11x, 15 times 11x on all of the numerators, and I'm allowed to do that because there's an equal sign, because I'm multiplying both sides by the same thing. I'm allowed to do that. On the first fraction, the 15 divides out, and you're left with 11x. On the second fraction, the x's divide out, and you're left with 15 times 11. And on the third fraction, the 11 divides out, and you're left with 15x. So we have 11x. 15 times 11 is 165. This is linear, so I don't have to do a lot of factoring or anything. So I get the x's on one side by itself, divide both sides by 4. So the answer is 165 fourths. So what the heck does that mean, huh? 165 goes into 4, let's see, 4, 1, and 1/4 left over. So we get 41 and 1/4 hours. And that's how long it's going to take Dylan to do it by himself. If I plug in 41 1/4 to the denominator, it's not going to make it 0, so we're good there. But let's just make sure that this kind of makes sense. Let's see. Joseph can do it alone in 15 hours. Dylan can do it by himself in 41 1/4 hours. So together they should be doing it in less time. And sure it is. Together they can do it in 11 hours. So you were expecting Dylan's time to be at least bigger than 11, because if they were working together, it should go faster. So this is clearly much larger, and that is our final answer. This completes our lesson on rational equations and word problems.